All right, so we're continuing talking about the Pythagorean Theorem, and if you remember, we said that the Pythagorean Theorem stated that if we know we have a right triangle, right, we're told that a right triangle exists, then a squared plus b squared equals c squared. Okay, so if you notice, all I did in this particular problem, if you're taking a look at the slide, is I just switched what we know and what we find out. Right, so instead of me knowing I have a right triangle, I know that c squared equals a squared plus b squared. I know that that works out. If I know that works out, then I know that I have a right triangle. Right? So we're going to be given problems where we don't know what type of triangle we have, but we know that if we plug into the Pythagorean theorem and it works, then we have a right triangle on our hands. Right? So this is what's called the converse of the Pythagorean theorem. I'm switching the if and the then, and we're making a different assumption. So let's take a look at an example and it will make sense. So they're just saying in this particular example down here that we have a triangle. Like, we don't know anything about this triangle. We don't know that it's a right triangle. So let me just draw myself just a generic looking triangle. We don't know what type of triangle this is. But they're claiming in this one, and obviously this is not to scale. Okay, we know this is not to scale, right? Because this 84, 85, and 13, this looks the same. Okay, but it doesn't matter. Okay, I'm just going to put sides of 13, 84, and 85, okay? So they're wondering, is it a right triangle? And so what we're going to do with this is we're going to say, I'm going to plug into the Pythagorean theorem, and I'm going to see if it works. And so the question is, if I'm starting with a squared, b squared, and c squared, which of these sides goes where? Like, which one do I put in for c? Which ones do I put in for a and b? And so if you remember when we're looking at right triangles, if this is a right triangle, then the hypotenuse is the longest side. And so this 85 down here would have to be C for this to be a right triangle, and so I'm going to plug that one into C. Okay, so here's what I'm checking. Okay, I'm going to put a little question mark over the equal sign because we're not exactly sure that this is going to work. All right, 13 squared plus 84 squared, does that equal 85 squared? All right, so I'm going to bring up my calculator. 13 squared is pretty straightforward. That's just 169. Okay. I do not know my 84 times tables, so we're going to use the calculator to help us out with that. All right, so I'm going to say 169 plus, and I'm going to come over here and say 84 squared. Okay, 84 squared is 7,056. And 85 squared is 7,225. Okay, and so the question is, all right, again, I'm asking, does 169 plus 7,056 equal 7,225? And the answer is yes, it does. If you add those together, you're going to find out that the left-hand side does equal the right-hand side. Okay, oops, 25. Okay, so this is true. Let me fix that. That's going to bother me. Okay, 7,225. Right. So I'm going to say yes, this works. When I plug in a squared and b squared, it does equal c squared. So I'm going to say, is the triangle a right triangle? Yes. Yes, it is. Why? Because the converse of the Pythagorean theorem works. A squared plus b squared does equal c squared. Okay, so that's kind of a simple application of, can we figure out if something is a right triangle, right? And so the question is, well, what happens if it's not a right triangle? What happens if it's something else, right? So we can actually use the converse of the Pythagorean theorem to figure out if something is an acute triangle or an obtuse triangle. And so here's how we do that. If we plug in, and a squared plus b squared does not equal c squared, but c squared is less than a squared plus b squared, then we know that we have an acute triangle. And if c squared is greater than a squared plus b squared, then we know we have an obtuse triangle. Right? And so what we're going to do is just plug in and see, and so we'll be able to draw a conclusion regardless of what happens when I plug in those three values. Again, we're always going to assume in any of these cases that c is the longest of the three sides. So here's a simple example. Okay, if I plug in, I'm going to plug into the Pythagorean theorem, and I'm going to say 14 squared, that's my biggest side, so that's my c, right? And then 6 squared plus 11 squared, and I'm going to figure out, I'm going to kind of leave this as a blank, I'm going to figure out which symbol I should put in there. Should I put greater than, which would make it obtuse? Should I put less than, which would make it acute? Or should I put equals, which would make it a right triangle? And so again, when I simplify this, I'm going to say 14 squared. Okay, 14 times 14 is equal to 196. Okay, 6 squared is 36. And 11 squared is 121. So if I add these together, it looks like I get 157, and on the left-hand side I have 196. So in this case, it's a greater than symbol, right? So I can say that c squared is greater than a squared plus b squared, and in this case that means that my triangle is obtuse. Okay, so let's just take a look at one more example of that so you can see the other way. Right, 7, 8, and 9 is a possible triangle, so I'm going to plug in and say 9 squared, right, and I'm comparing that to 7 squared plus 8 squared. We're going to find out what happens here. So again, I'm going to leave myself a nice little blank here. Remember, acute is if I get a less than in between this, obtuse is if I get a greater than, right is if I get an equals. Okay, so if I simplify this one, this is 81. This is 49 plus 64. Okay, so I could put these together. This is 113. Okay, and in this case, 81 is less than 113, which means c squared is less than a squared plus b squared. So I'm going to call this an acute triangle. Right, so we can actually take the converse of the Pythagorean theorem and not only determine whether something is a right triangle, but determine if it's not a right triangle, is it an acute triangle or an obtuse triangle.